Okay, well, let's use this approach to work on this next problem. So let's find the zeros of a polynomial function given in this format using a combination of graphing and synthetic division. First, let's notice the degree. If the degree in this case is 4, that tells me I'm looking for 4 zeros. That's always going to be the case. The degree tells you how many you're looking for. We're going to use a combination of graphing and synthetic division, so pull out your calculator and let's get that equation typed in. Let's go to y equals and clear out what you have there, and while I type it in, you type that into your calculator. Let's get a graph and see if we can find any rational zeros from the graph of this function. I'm going to go to the table, see if it shows me any. Aha, there's one. Right there at 2. So what my graph is doing is it's bouncing at the number 2. That tells us something really important. It tells us first that there's a 0 at the 2. So there's the 0 we can find from our calculator. I don't see any others. There's just the 1 right there at 2. So from the calculator, we see that 2 is a 0. Now, I'm going to guarantee you that if this is a if you've got a 4th degree, you should be able to get 2 from your calculator, so you can get it down to a quadratic and find the last 2. Problem is, on the calculator, I only see 1. Right there, the number 2, I don't see anyone anywhere else. But I've given you 2. Can you see what the second one would have to be? It has to do with the bouncing aspect. If your graph bounces on an X-intercept, what does that tell me? It tells me multiplicity. It tells me that the multiplicity is an even number. Multiplicity, remember, is how many times it's repeated. So if the multiplicity is going to be an even number, then that means this thing is repeated at least 2 times. It could be 4, it could be 6, but I've got to watch out my degree. My degree is 4 here. So this 0, since it bounces, it can't repeat 6 times because I'm only looking for 4. It can repeat 2 or 4, but I'm going to always start off with 2. Big thing you got to watch out for bouncing zeros. Count them at least twice, maybe more than twice, just depends how the rest of the problem goes. So from the calculator, we see that 2 is a 0, and it is a repeated 0. We're going to say it's repeated twice. I don't know if it's 4 times yet, but I know at least twice. Well, we're going to use a combination of graphing and synthetic division, so my next step must be synthetic division. And let's use the number we found on the calculator, making sure we put a 0 in for the missing 3rd power when we do our synthetic division. Yep, when I divide by 2, I get a remainder of 0. Problem is, this is a cube, not a cube. What did it start off as? Fourth power. Then it drops down to a cube. I'm still not at a quadratic yet. I'll stop once I get to a quadratic, but I'm going to, since it bounced at the 2, and it means it repeats at least twice, I'm going to do the 2 again. I'm going to divide by the 2 again. Should get a remainder of 0. Let's check it out. And yep, I get a remainder of 0. By doing the repeated synthetic divisions, because that was a repeated 0, that repetition caused me to get this thing down to the magic quadratic. X squared plus 4x plus 6. Well, you know, once you're down to a quadratic, if it doesn't factor, and this one doesn't, we're going to use the quadratic formula. So recalling the quadratic formula, then putting in negative b squared minus 4ac all over 2a gives us this quantity under the radical, 16 minus 24. Under the radical, we're looking at negative 8. And that negative 8 as a radical reduces to a 2 square root of 2, but since it's negative, that's where our imaginary thing comes from, our complex 0. Imaginary 0, however you want to call that. Notice the I is not under the radical, it's completely separate from that. And finally, this result is going to reduce since all 3 of these numbers are divisible by the same amount. I end up with negative 2 plus or minus the square root of 2 with an I hanging around at the end. A note here, these 2 guys are imaginary. We would have never found those on the calculator. The calculator will only give us real zeros. Another thing is, anytime you have imaginary zeros, they will always occur in pairs because they will come from the quadratic formula, and when you use the quadratic formula you always get conjugate pairs. Well, let's list out our zeros. Let's list all these guys out. There's 4. 2 is one of them. 2 is another one. And the other 2 come from negative 2 plus the square root of 2 with an I, and a negative 2 minus the square root of 2I. Those 2 last ones are imaginary. Make sure you write the I separate from the square root. And so that's how we can use a combination of graphing and synthetic division. Now, it doesn't matter if it's a polynomial function or if it's a polynomial equation. Solutions or roots to polynomial equations will be found the exact same way we found zeros to polynomial functions. So solutions are found the same way as zeros. Which means we'll use our combination of, let's go to the calculator, see what we can get from the calculator, and then from there get it down to a quadratic. Now we're looking for a total of 3 here. Let's get in the calculator and see what we can find from there. type it in and get the graph. Well, I'm seeing it crossing at 3 spots. So I'm seeing that there's some on the calculator. Let's go to the table feature and see if it's gonna give us anything specific. Looking for a 0 in the y position. And I don't see one. There is something there. There's going to always be something you can get from your calculator. Let's just try a different place to go. Can't get it from my table. There's my graph. Let me show you a nice window to go to, which is Zoom 4. Zoom decimal. If you have a decimal equivalent 0, in Zoom 4 you should be able to trace and find it. I went to Zoom 4. There's my picture. I'm going to hit the trace button and see if possible as I trace in Zoom 4 it'll show me anybody that was a decimal. Now, pass that guy up, so that one's not one I can get from a calculator. How about over here? Aha! There is one at a half. I went to Zoom 4, and I'm using the trace feature, and I'm tracing right and left just to see if I can find anybody that happened to be a decimal value. And I did find one, which is 1/2. Oops. So let's use that as our starting point. 1/2. What I did here is I went to Zoom 4, then I hit the trace feature, and from there I was able to trace left and right. Find x equal 1/2. Got to have a starting point. Guaranteed you'll get a starting point from your calculator. In this case, our starting point will be 1/2. So we'll divide synthetically by 1/2, making sure we put zeros in for missing terms. 1/2 of 4 is 2. 1/2 of that will be -2, and 1/2 of that is -1. Bang! 0 remainder. I expected that to happen. Now let's look at the quadratic. 4x squared minus 4x minus 2. I knew this was quadratic because it started off as a cube. You divide once, you get a square. This one's not going to factor. And let me tell you something about quadratics, something you can do. I'm noticing that this quadratic, they all have a 2 in common. What I could do is factor out that 2 and just make this quadratic a little bit easier to work with. 2x squared minus 2x minus 1. Just factor out a 2 from every term, which means when I go to use my quadratic formula, I can use it on these numbers and just have some smaller numbers to work with. So let's go to the quadratic formula. I'll bring it up here. So it'll be 2 plus or minus the square root negative b plus or minus b squared minus 4 times a times c all over 2 times a. And notice I'm just using the smaller values here, the quadratic, after I factored out the 2. Under the radical, we'll get 12. And that radical reduces to a 2 square root of 3. and that whole quantity is divisible by 2, which gives me a reduced result of 1 plus or minus the square root of 3. You got to have that 1 there to hold its place. It's like 2 divided by 2 and 2 divided by 2. This 1 is necessary. The 1 in front of the radical isn't. As far as our list of zeros, we have the 1 from the calculator of a half, and the 2 from the quadratic formula, 1 plus the square root of 3, 1 minus the square root of 3. These guys are called conjugates. They always come in a pair from a quadratic formula, or from using the quadratic formula.